There are many ways to achieve consensus, and different methods are used across different blockchains. One very successful consensus algorithm is known as proof of stake. In this video, we'll cover how proof of stake works, potential challenges it faces, and who's using it. Proof of stake is a consensus algorithm that seeks to achieve consensus by giving votes to those with stake. Stake in this case means those who have the most investment in a positive outcome for the system. These users are considered the most likely to vote on making a positive impact on or improvement of the system. How does proof of stake work? In the proof of stake consensus protocol, there are no miners. Instead, there are validators. These validators do not need to invest in computing equipment to mine the blocks that create coins, because all the coins exist from the outset. Instead, the purpose of these validators, also known as stakeholders, is to determine which block makes it onto the blockchain. In order to validate transactions and create blocks, validators put up their own coins as stake. You can think of it as if they were placing a bet. If they validate a fraudulent transaction, they lose their holdings, as well as their rights to participate as a validator in the future. In theory, this check incentivizes the system to validate only truthful transactions. In proof of stake, the greater the fraction of the total coins a validator owns, the higher their chances of being picked to create the next block, because they have a higher stake. A validator node with 400 coins will be 4 times as likely to be chosen compared to a node that only has 100 coins. If a validator's block is added, the validator is awarded coins proportional to the amount of their bet. With that said, this begs the question, isn't it possible for a bad-acting validator not to lose anything by betting on multiple blocks so they always win out in the end? Ah, very good. You've stumbled across what's referred to as the nothing at stake problem for proof of stake. There's something about blockchains that we haven't mentioned before, the possibility for that single chain to fork. When a blockchain is extending under the proof of stake paradigm, it's possible a fork in the blockchain can occur, either accidentally, for example, if some nodes receive information to add one block while others receive an update to add another block, or because there is a malicious attempt to rewrite the history and reverse a transaction. In other words, if there are multiple competing block options, isn't it possible for a bad-acting validator to just place bets on every block so they always come out on top? It's true, these are possibilities, but proponents of proof of stake have strategies against these types of attacks. One strategy is a slasher solution, which entails penalizing validators if they simultaneously create blocks on multiple chains. Alternatively, some protocols use a strategy that punishes validators for creating blocks on the wrong chain. In this method, validators must be selective and conscious about which blockchain they put their stakes in. Who uses proof of stake? Ethereum is switching from proof of work to proof of stake in a project codenamed Casper. Digital Cash, or Dash, is one of the pioneers of proof of stake algorithm. It's built on the core Bitcoin platform, but with added privacy and speedy transaction features such as private send and InstaSend. There's also Lists, designed to allow developers to create their own decentralized apps, similar in function to Ethereum or Neo, but allowing developers to use JavaScript. Lists uses a customized form of proof of stake, called delegated proof of stake. This just means that only the top 101 delegates are able to have stakes in the network, and these delegates are voted on a rolling basis by the community. One list equals one vote. Now that wraps it up for proof of stake. The next method of consensus we will cover is delegated Byzantine fault tolerance, DBFT for short.